Let's go through question 1 in this video. We're going to work with partial derivatives. And the idea of partial derivatives is that we have functions that have more variables, but then we want to differentiate only with respect to one variable. So for instance, in this case, we want to find the rate of change of the function when we increase x by 1 unit only. So that means that our variable of interest in the entire function will be only x. Everything else, y and z, and any terms with y and z are going to be constants. For instance, what is the derivative of the function with respect to x? From here we have 2x, and from the other term we can see we have no x inside it, so there is nothing to be changed because there is no rate of change, so it's gonna be 0. So the derivative of the function with respect to x is just 2x. Let's solve part B as well. So we have a function g that depends on t and s, and that's equal to e to the power of st. E to the power of st. And we want to differentiate the function with respect to s only. So g derivative with respect to s. That's e to the power of st. And because we don't have just s here, we don't have just our variable of interest, we have an expression of our variable of interest, we're going to use our chain rule. So e to an expression derivative, that's e to the power of the expression times the derivative of that expression. So in our case we're going to differentiate st with respect to s. Okay, so that's e to the power of st times, what is s times t derivative with respect to s? Well, that's a constant, right? T times the variable of interest. Well, the constant comes out, which is t, and the variable of interest derivative, what is the derivative of x with respect to x? It's just 1. So in this case the derivative of s with respect to s is also going to be 1. So t times 1, which is t. The final answer is just e to the power st times t. Let's leave it like that for this video. In the next video we'll go through part C.